Hi teachers, this is Jamie with Science Central, and we are going to look at the volume and measurement lab for 3rd grade, so stay tuned. Okay, so this measurement lab really revolves around two concepts, concept of volume and mass. Students generally get them confused or mixed up, or also they may think that they are the same. If an object has the same volume, it must have the same mass. So through this lab, they start to recognize that in fact those are not the same. They're totally, completely different concepts. So with this lab, it'll explore those different things. So day one, they'll go through the learning targets. They will also answer a quick little question on the front of the slag, a fishy question, and particularly looking at the beaker and the graduated cylinder and the pipette. So having them understand that, and make sure that you use the right tool for whatever you're doing, and talking about being accurate and precise. Why it's important to be accurate when you're doing measurements. So the first day really looks at the opening. So let them look at the fishy question, have them talk about it, and then it does go right into the first activity, which is what we call the squirt fish activity. Also on day one is a great brain pop on precision and how to use tools. So that's a great quick little content resource to use. And there's also a couple different PowerPoints that you could pull up for this lab as well. So day one we call squirt fish. So each group of students will get a little squirt fish, and they should also have a graduated cylinder. I usually have the one that goes up to 100 milliliters, and a beaker. That one goes up to 500 is good, or higher. There might be some that are 600. That's fine. So for this one, what they're going to do is they're going to fill up the beaker at 400 milliliters, and then they're going to fill up the fish with as much water as they can. So they'll fill that up, then they'll take their graduated cylinder and empty the fish into the graduated cylinder. Then on their data table, and there's step-by-step directions in the slag. So I would definitely preview that beforehand and make sure you understand those steps. Maybe even do it yourself before you do this. Then they will measure how much water was in the fish precisely. So make sure, I always tell them, get down to eye level so you can read the numbers. Make sure they know how to read the numbers. Can they actually, do they know what each one of these lines goes up by? All tools have different scales. They'll notice this scale is a lot different than the scale on the beaker. So we really want them to see that. So they'll measure that and record it on the table, how much was in the fish. And then they're supposed to look at the beaker and see how much water was left in the beaker. And they're probably going to notice that it's a lot harder to be accurate with the beaker than the graduated cylinder. So they might have to do a little bit of math. If they know they started with 400 and then there's, 78 in here, they could do a little math to figure out how much is left in the beaker. Because they just can't eyeball it, and they would be guessing. So the idea is the graduated cylinder is a lot better to use for accuracy than the beaker. So they'll run that 3 times, 3 trials, so starting back. So I would have a couple beakers per group, so that way they can pour the water back in to different things if they need that. So starting at 400, filling up the squirt fish, and then emptying the contents. There's also funnels that should be with the kit, so they can use the funnels and pipettes, and let them know if they spill the water, they're losing milliliters. About 4 drops of water is about 1 milliliter. So if their data is coming out strange, are they reading the tools correctly? Did they spill any of the water? Students really liked it. It's a lot of fun. But just that opening is just talking about being precise, being accurate, and how to use the tools accurately. You could even start bringing in volume. Like volume is how much space something takes up. So, and a lot of kids don't understand that air has volume. So right now, they would say, "Oh, the fish is empty." Well, there's air in the fish, so it does take up space. And then we add water, which takes up space. So you can start bringing in volume here with, the volume of what was in the fish. It takes up space. So having them say that is very helpful. Then moving into the second day, which is also a lot of fun, we start looking at does shape matter? So each group will get a piece of clay. And actually has how festive red clay. You might not have red clay. You might have just the regular clay. We do send out refurbished clay every year. So each group will get a piece of clay, and then they're going to talk about does shape matter. It does have volume. Talk about the properties of the piece of clay, and also talk about the properties about water. So make sure on day one you could also talk about that. So they're going to get their piece of clay, and they're going to make sure it fits in the top of the graduate cylinder. So if it's too big, it won't go down in the graduate cylinder. So it's got to be able to fit in the graduate cylinder. So they'll make a shape. They can roll it into a ball or whatever. So they can make their shape as long as it fits in there. And then they're going to pour water in the graduated cylinder up to 50 milliliters. So then they'll have shape 1. They'll put that data in the data table for shape 1. They're not going to change their shape until they do a couple trials here. They'll do the start volume, and then they will drop the clay. I tell them don't do it like this. If you do it at an angle, it won't. We won't have some spillage. So remember, we want to talk about that. So they'll watch that the water level will rise. So start at 50. Let's say it goes to 75. There they would do a little bit of subtraction. Math and science. And once they do the subtraction, that gives them the volume. How much space did the clay take up in the graduate cylinder? So that is focusing on volume. So they'll do that 3 times with shape 1, and then they'll change the shape. I get a lot of students that'll even break the clay into 2 pieces and see if that makes a difference. They'll find if they do it correctly, they should get the same data no matter how they change the clay. They should get the same volume for the clay no matter what. If they get different data, and a lot of kids, they'll think 1 off is this dramatic change. So let's say they got 15 one trial and 14 another trial. That is not a huge difference. That could have been spillage or whatever. Sometimes students think that just 1 value off is this huge change. So if they get like 15, 14, 14, oh no, it's not the same. Come on, it's pretty close. It's the same thing with temperature. If you get 84 degrees and then 85 degrees, they think that's a huge change. It's not. You could be off by a degree or a milliliter. It's not significant. So that's a good conversation to have. They'll do that piece. Trial the next one. They'll do changing the shape and do that 3 times. And then at the bottom, we want them to see if mass changes. So we want to look at mass now. So they'll do shape 1 and find the mass using a scale. You got plenty of scales. I like these bucket scales. There's other types of scales too. I also love the plastic weights that has numbers on them. So they will find the mass of the clay and do that, and then change the shape of the clay, break it up, and then find the mass. They should see that it, in fact, the mass stays the same. I have a lot of teachers that like to do the mass first and then do the volume. That's totally up to you. I have no problem with that if you want to do the mass first of the clay before, or do it in conjunction. That would be totally cool. That's totally fine, as long as they do both. They get those both pieces in. And then remember, at the end of each of these days, there are some follow-up questions that have the students think a little bit more about these concepts. Okay, the final big activity. So it's broken, and we had a few years ago we had many more activities, but we kind of got it down, especially for third grade, to these three main activities for time, to make sure we want these three to be done with fidelity. So that's very important. I like this last one. It's a lot of fun. I think this one really brings it home because it's about mass and volume and really tying them both together. So for this last day, each group gets a nylon ball and a steel ball. And what they will do is first kind of see, do they have the same mass? Same mass, and also do they have the same volume? So I tell them to hold them in their hand, let them feel, oh, this, the silver ball has more mass, it's heavier than the nylon. So they think, here's what they think volume and mass are the same. So if it has the same mass, it must have the same volume, or vice versa. So what they will do is actually measure that. They will find the mass of both the steel ball and nylon ball and record that, so they'll need to use the scale there. And then automatically they think they have the same volume. Or actually, I'm sorry, they'll think because the steel ball is heavier that it will have more volume than the nylon ball. Sorry, I said that wrong. Got it mixed up. See? Happens to adults. So they think that this is heavier, it must have more volume. And what this experiment will show that that is not the case. Just because it's heavier doesn't mean it has the same volume or less than. So first thing, they'll measure the mass of these two, and then the next part, they will actually find the volume. So again, they will measure water, 50 milliliters, accurate. Then they'll take the first ball, that can be the nylon, or it doesn't matter. And then they will, I always tell them, tilt to the side so they don't get the spillage, and let that go into the graduated cylinder. The water will rise, it's that displacement method, and then they will calculate the mass of the ball, the steel or nylon ball. So they'll subtract the ending from the beginning to get the mass of the nylon ball, and then they'll do the same with the steel ball. Remember, they do a couple different trials, at least 3 trials. If we had more time, we'd do more, but we want to make sure we get through all of this. They should find out that, in fact, the nylon and the steel ball have the same volume because they are the same shape. They are the same shape, they're going to take up the same amount of space. Volume is how much space an object takes up based on shape. So the same shape. However, then the steel ball has more mass. It's heavier. So that's going to be different. Mass is going to be different, but volume is going to be the same. And so remember, there's a follow-up question at the end of this particular activity, and also there's a place where they can sketch. We've been working with liquids, with water, and different solids, so having them do a little sketch or illustration of the difference between solids and liquids. Especially with the water, it took the shape of the beaker, it took the shape of the graduated cylinder, it even took the shape of the fish. But when you did the clay stayed its shape when you dropped in the water into the graduated cylinder, and also the steel ball or nylon ball also kept its shape because they're solid when you put them in the graduated cylinder. There is an optional activity. It's not in the slide, but if you wanted to further do some things with volume, there's the volume of the box activity. So you give each student 10 to 20 of the little blocks that are in the kit. They build a little house or something like that, and then they put it into the graduated cylinder and find the volume. What we get out of that is the number of blocks that they use will equal the volume of their house that they make. So if they used 10 blocks, they're going to find that the volume is also 10. If they use 20 blocks, they'll find that the volume of the house is also 20. So hopefully they come up with the conclusion that each one of the individual blocks is exactly 1 milliliter. So it's really cool, another way to see that. And they can even do mass for that as well. Optional activity, but definitely do the 3 that we discussed on this video. There's also some great exit questions for this lab on the back of the slag, and as always, make sure you do your post-test. Thank you for joining me, and we will see you next time on Science Central.